Hello everyone, and welcome to this video on the Python programming language. So in this video I'll show you the magic power of compounding. Now I'm currently on Google's website. It's called colab.research.google.com. It makes it really easy to start programming in Python. So if you're going to program along with me, go to this website, log in using your Google account, and then click on File, and then click on New Notebook, and a new tab will open up for you, and then eventually a new cell will open up for you. Now, before we begin, if you like the videos on this channel, then be sure to click that subscribe and like button. Also, you can get the code or just support the channel on Patreon at patreon.com/computerscience. I will leave a link for that in the description below. And the material in this video is purely educational and should not be taken as professional investment advice. So be sure to do your own research before making any sort of investment. All right, so with all that being said, let's go ahead and get started. The first thing that I'm going to do is I'm going to import the libraries that I need for this program. So I'm going to import matplotlib.pyplot, and then I'm going to run this cell by clicking this button here to the left, and then I'm going to create a new cell by clicking that code button in the top left. All right, so now I'm going to create a function to calculate compound growth with contributions. So I'll first show you how $100,000 can turn into $1 million in just a few years. All right, now let's go ahead and create this function. So just type def, and then I'm going to call it calculate underscore compound underscore growth underscore with underscore contributions. All right, a long name for a function, but that's okay. All right, we're going to take in a few parameters. So we need the principal amount, we're going to need the target, we're going to need the rate of return, and we will need the annual contribution. And with this information, we can just do some math through a loop and get our answers. So I'm going to create a variable called balance underscore over underscore time. I'm going to set it equal to our initial principal amount. I misspelled principal, so principal. Okay. All right. Next, I'm going to set years equal to 0. Now, I'm going to create a loop that's going to continue until we hit the target. So, create a loop until we hit the target. All right, so I'm going to create a while loop. So while the principal is less than the target, we're going to continue this loop. And we're going to update the principal. So I'm going to set principal equal to principal times 1 plus the rate of return plus the annual contribution. Okay, and if you multiply this out, this is just principal plus principal times rate of return plus annual contribution. All right, next I'm going to append to our balance over time list. So I'm going to set this, I'm going to do balance over time dot append, and I'm going to append that principal amount. Okay, and then we're going to add 1 to years. So we can set years equal to years plus 1, or I can just type years plus equals 1. All right, so that should do it. And now I just want to return years, and I'm going to return balance over time. All right, so let's go ahead and run this cell. And now the concept here is that once you've accumulated $100,000 through savings and investment, the power of compounding returns means that your money starts to work for you more effectively. And so with this program, I'm going to I'm going to kind of demonstrate this. So let's create a new cell now, and let's show this visually. But before that, let's get the initial investment amount, the target amount. We're going to get the annual rate of return and the annual contribution. So let's go ahead and get all that stuff. So here I'm going to get the initial investment. All right, so I'm going to create a variable called initial underscore investment, and I'm going to set this equal to 100,000. So we're going to start off with 100,000. And don't worry if you don't have 100,000. I'm going to show you some other things with the plot that's pretty interesting. All right, so next we're going to get the target amount. So I'm going to create a variable called target underscore amount, and I'm going to set this equal to 1,000,000. Okay, and let me just double check. This is 1,000,000. 1, 2, 3, 4, 5, 6. Okay, so we have our target amount being 1,000,000, and then we're going to get the annual compounding return rate, and we're going to get this as a decimal. So I'm going to create a variable called annual underscore return underscore rate. I'm going to set this equal to 0.07. So we're just going to expect a average rate of return of 7%. All right, and next I'm going to get the annual contributions. So annual underscore contribution is going to be equal to 0 for now. Okay, so with these 4 parameters, we're going to be getting our initial investment, our target amount that we want to reach. We're going to get the annual return rate and the annual contribution. All right, so I'm going to go ahead and run this cell, and creating a new cell. Actually, you know, in the previous cell, I'm going to do one more thing. I'm going to calculate the number of years and the balance over time with contributions. So I'm going to create 2 variables. One will be called years to target, and the other one will be called balance over time. And I'm going to set this equal to our function, which was really long. So I'm just going to highlight this function name, the really long name. I'm going to copy using Control C, come down here and paste it using Control V. All right, and then left parentheses, right parentheses, and then I'm going to put in the parameters. So for the principal, it will be the initial investment, and then for the target amount, right, that's the next one, is target. I will put in target amount, and then I'm going to put in annual return for the rate of return. So that's annual underscore return underscore rate. And then for annual contribution, I'm just going to put in annual contribution. Okay, now let's run this again. All right, everything's good. All right, so this will give us the years until we hit our target as integer values. So it's going to be approximate, right? So it should never be more than whatever this value is. It should not take any longer than that if that annual return rate is consistent. And then of course the balance over time. All right, so what the balance will be at each year given these parameters. All right, so now that we've done all that, let's actually start plotting the investment growth with contributions. All right, so I'm gonna type plt.figure. I'm gonna give my figure a figure size, and the figure size will be equal to 10 by 5. And then I'm gonna type plt.plot, and we're gonna plot our balance over time. Okay, I'm gonna set a marker here. The marker will be equal to 0, and then I'm going to give this a label, and the label will be with yearly contributions, and maybe I'll put growth with yearly contributions. All right, so I think that's good. Let's go back up here, and I type PLT, and you can see that there's an issue. So I'm gonna go back up here, and where I have the library, I'm gonna import matplotlib.pyplot as PLT. All right, and then I'm gonna run this cell, and then we should be able to use that PLT down here. All right, good. Okay. So next, let's go ahead and give this plot a title. So I'm gonna type plt.title, and I'm gonna call this investment growth over time with yearly contributions. All right, let's give the x-axis a label. So I'm gonna type plt.x label, and the x-axis label will be years. And let's give the y-axis a label. So plt.y label, and I'm gonna put balance in USD. And let's type plt.grid, and let's make this true, and plt.legend to see the legend, and then plt.show. All right. Okay, and I'm going to add one more thing here. I'm going to create a print statement. So type print and then put F here, and then quotes, and we're going to put with an annual contribution of some amount, and the amount will be annual underscore contribution, comma, it will take about some years. So I'm gonna put years to target, and really I can also, instead of saying about, I could probably say no more than, but we'll just keep about for now. So it'll take about years to target years to grow your initial investment. So we're going to grow the initial underscore investment to some other amount, which is our target amount. Okay, and then with an annual return rate of, and we're going to get, of course, the annual underscore return underscore rate. And then I'll put a percentage sign and put a dot here, and I'm going to multiply this by 100. And actually I'm going to round all of this, so I'm going to put round and then comma 2, because we're going to round it 2 decimal places, and then in the parentheses here. Okay, so with all that being done, let's go ahead and run this, and let's see what this program looks like. Okay, so here we go. So now we can see if we start off at 100,000, and I know over here to the left it doesn't look like 100,000, but you'll see this 1E6. So here would be 1,000,000. Here's 800,000. Here's 600,000. Here's 400,000, and then 200,000. So we're starting off at 100,000, and we can see that it would take about a little less than 35 years to reach 1,000,000, right? Because we reach 1,000,000 somewhere around here. So this program is going to tell us that it's going to take about 35 years, but it actually takes less than 35 years to reach $1,000,000, given that the initial amount that we put in an investment that grows at 7% per year. We have our initial amount of 100,000 with the 7% growth per year. It will only take us 35 years, actually less again, to reach $1,000,000, which is pretty cool, right? Now, what's neat about this program is we can change some of these numbers, and we can see how our investments will grow. So this is really, really cool that we can see the magic of compounding just like this. So, all right, let's take a look at how long it takes to get to the next $100,000, right? So we start off with $100,000 here. Here's 200,000 right up here, and so it would take about 10 years to get from 100,000 to 200,000, given this return rate of 7%. And to go from 200,000 to, let's say, 400,000, it actually takes another 10 years. So we're getting 200,000 now in the next 10 years instead of 100,000. So you can see the growth rate is increasing, right? It no longer takes us 10 years to get to another 100K. It takes us 10 years to get to 200K now. All right, so now let's see how long it takes to get from 400K to, let's go with, I don't know, 600K, right? Another 2 years. So we hit 600K somewhere around here, right? And that's just a little more than let's see, a little more than 5 years. So that's pretty good. So we increase our balance by $200,000 in less than 10 years, which is amazing, right? So we can just see this rate of return is increasing and is wonderful. All right, so let's go ahead and change some of these parameters. Let's actually add some contributions. So let's add an annual contribution of $10,000. So let's say that you want to contribute $10,000 to this portfolio that's giving an annual return rate of 7% on average. Actually, let's go ahead and increase that to 10%, right? So we're going to put 0.1 for 10%. And you can, or I shouldn't say you can get this, but the S&P 500 has returned about 10% on average now. So I'm just going to put this to 0.1. Our initial investment will stay, well, actually our initial investment will go down to $10,000. So let's say we have $10,000 initially. We want to get to $1 million. Our annual return rate is 10% because we invested in the S&P 500 a long time ago, and we are contributing $10,000 a year to the portfolio. What does everything look like now? So let's go ahead and run this cell. Let's run this cell, this plot. And now you can see that we have cut down the time that it takes to reach $1 million, right? So even though we start off with less money this time, which was $10,000, we continuously contributed $10,000 to this, and our rate of return is 10%. So it took less than 25 years to reach $1 million, which is pretty cool. So with an annual contribution of $10,000, it will take about 25 years to grow $10,000 to $1 million with an annual return rate of 10%. All right, this is wonderful. So this is just the power of compounding and the power of math to see these rates of returns and what you can do with consistency. And of course, these annual rates of returns are assuming that this stays consistent or is on average. So of course, your investments may fluctuate, or a investment may fluctuate, but this is just really interesting. So let's go ahead and change this initial investment to 100,000. Let's run this cell again, and let's run this plot. Okay, now it's only going to take us about a little over 17.5 years. So it's going to take us about 18 years, right, to reach $1 million. So with an annual contribution of $10,000, it will take about 18 years to grow $100,000 to $1 million with an annual rate of return of 10%. Okay. So this is wild. It's very possible to do this, at least mathematically, right? So that's basically it. You can continue playing with this and changing your contributions, changing your rate of return, changing your initial investment, and changing your target investment or your target amount. So with that being said, thanks for watching the video, and a special thanks to the Patreon supporters on patreon.com. Again, if you want to get the code or just support the channel, you can do that by going to patreon.com/computerscience. And again, I will leave a description to that. I will leave a link to that in the description below. All right, thanks for watching, and I hope this was interesting, and I hope it was entertaining and insightful, and I hope you all have a wonderful day, and I'll see you all in the next video.